everyone, and today we will be seeing one of the problem from Geeks for Geeks. It says minimum multiplications to reach end. Now the problem is pretty simple, that we are given two integers start and end along with an array of integers ARR. In one operation you can multiply the current value by any element from ARR of from ARR of the array, and then take the result modulo 1000 to obtain the new value. Now we need to find the minimum steps in which end can be achieved starting from start. So if it is not possible to reach the end, return -1. Well, cool. So we have an array, we have start as 3 and we have to go till 30. So if I take 3 multiplied by 2, it will get 6, and if I take 6 multiplied by 5, I'll get 30. So that is how it works. And again, same goes with example 2. I have 7 multiplied by 3 to get 21, again multiplied by 3 to get 63, again go ahead and multiplied by 65, I get 4095, but this is obviously above 1000, so modulo it to get 95, multiplied with 65 again and get 175, which is the end. So yeah, that is how it works, and we have to solve this one. So how can we achieve this? So there are multiple ways to achieve this one. We'll take the simplest route as possible, and which can be efficient as well. There are some inefficient ways as well. So one inefficient way, which is brute force approach, is something, try all the combinations, try all. So you have two options for each array element, either to take it or not take it within the multiplication substitution. So that will leave you to 2 to the power n, and that will take your start to end, and it will generate 2 to the power n combinations by taking what all things we have within A. And again, this is brute force approach. This is not very efficient. As you can see, it's exponential, so we are not going to use it. So other approach is, you can find it out that, hey, I am on start, I need to go to end. So first of all, is it possible from start to go to end? There need to be a multiplier. So something like, let's say x. So start multiplied by x is equal to end. So this should happen. So for that x, if it is an integer value, then end modulo start should be equal to 0, and that's the basic condition. But again, will it rely true? Will it be true or not? That's a question, because again, we need to modulo everything with 1000. So this modulo with 1000 gives us an error. It would mislead us, not error, but would mislead us into multiple scenarios. So this solution also might not work for certain cases. There is also try out limited options. Now what is try out limited options then? So we have, within the example, if I take it, 257, 330. So if I need to go from 3 to 30, and I have 2, 5, 7, then how would I go? I have a limited option. I can take this one, and I can take this one, and this has multiple options as well. So if I am taking 3 with this multiplied by this one, then I also get another value. So I'll generate it with I'll take it the number actually. So this is 3, which is coming from start, and we get 6 as a new value. So I can take this 6, which is newly generated as well, with 5's value, so 5, 2. So all of these things, when you come up with this, like if I'm taking with 3 again, getting it as 3 5s of 15, again 6, getting it with 5 or 6 attaching with 15, I can take 6 and 15 both as well, and this can lead me to 16 into 5, 6 into 15, what is it, 90. So such kind of things I can get into. So yeah, this generates a complex graph kind of structure, and we need to traverse each and every node. Not each and every node every time, but yeah, most of nodes we need to traverse until and unless we reach 30. So there are two approaches to do this, either DFS or BFS. DFS would not work. I'll tell you straightforward why. So by the nature, DFS goes to the depth. If I'm getting 2, 3, then 6, then I'll go back into the depth. That is 6 multiplied by 2 again, which is 12. 12 multiplied by 2 again, 24. 24 by 2 again, 48. And so on and so forth, until and unless I reach, cycle back. So DFS would not work. And why I'm cycling back? Because it's already modulo 1000. BFS would work here, because it doesn't only take care of one particular set, but has accountability of each step. So you can track each step one by one happening just in front of your eyes with BFS. So with that thing in our mind, let's get started. We get a graph, but we are not going to generate the graph right away, but we are going to understand that hey, if start actually is equal to end, so we don't need to even traverse, so return 0. In that case, we are true, and obviously we are using BFS, so one thing we need is Q of int array, and I'll call it as Q new linked list, and again it's int array. That means the first one is a value which I'm currently holding, and next one is a step. Step means how many steps I took. So for example, if I'm starting at start, so I'm currently at start, right? Start, and I have taken 0 steps, so 0. Cool. Again, how many visits I can do? I can do 1000 visits, because it's obviously modulo. So boolean visited is equal to new boolean of 1000. Again, it's an array. Cool. With that thing in our mind, I have Q initially set up. Let's go while I'm seeing Q is not empty. And once I'm getting, I'll take the current out of the Q, which is Q dot poll. I'm taking the value part aside, which is current of 0. I'm taking the step part aside, which is current of 1. Again, a quick check, value is equal to end, then I'm done here, return step. But if not, what should I do? If not, I should check to try what I'm writing. I should try every element within the array. So for every element in n within array a new value, which is, let's say, x, is equal to n multiplied by our current value. Obviously this x can go beyond 1000, so x modulo equal to 1000. Now I'm checking that hey, if I have already visited the x, if I have already visited x, I'll continue back, because again no point in reiterating the same numbers. But if not, then what I should do here is I should check. First of all, I should check, if x is equal to n. If x is equal to n, then just return step plus 1. And if not, then I need to just fill it within the queue again back. So queue dot offer new int of the current value x we have, and I'm taking one more step, so step plus 1. Cool. And I'm using visited array, so I should populate it somewhere. So I should do right here, visited of val is equal to true. Yeah. Cool. Now this loop will go again and again, finding out each and every time with each and every element within the array, and ultimately it will stop the moment it sees q is empty and I'm not able to find any other element apart from this, and at that moment I can say that hey, it is not possible, so return -1. So cool. This is a logic for this. Let me try to run this one. Yeah, it runs for sample test cases. Let me try to submit this. It says time limit exceed. What is wrong? So I visited for x and I continue it. Shall I put visited right here, or I should not? Cool, I can take just right here because visited of x is already true. I've counted it, I don't found it anything, and I should put it here as well. Visited of, step, no, not step, value is equal to true. This would save me some iterations, I guess. Yeah, it worked. So time taken is still 0.08 seconds, and this was one of the problem, saying minimum multiplications to reach the end. It kind of followed the track of BFS and traversal. If you wanted to see more such kind of algorithms, click the video on your right, and I will see you in the next one.